Hello, this is Caitlin Ostendorf, and I am doing the Jsw problem. The problem states an object with a height of 25.5 centimeters is placed 35.5 millimeters to the left of a lens with a focal length of 30 millimeters. And there are two questions. A, where is the image located? And B, what is the height of the image? To get a better idea of this problem, I would first draw a ray diagram of it. So here we have our object, and our object that has height of the object, which is 25.5 centimeters right there. And then we have our lens, and the focal point with the length of 30 millimeters. And I'm going to start with the P ray, which goes straight, then through the focal point. I'll put a P for that. And then we have the mid ray, which just goes through the middle right here. And then lastly, we have right here. Lastly, we have the F ray. The F ray goes through that point, across, and then meets up with these guys over here to form the image. And then also right here, we have the object to the lens. That's the distance of the object. And over here, we have distance of the image. And so this problem tells us we have distance of the object equals 35.5 millimeters. It also tells us the focal length, which is 30 millimeters. And with that information, we can try solving part A. We can use the thin lens equation, which is this right here. And we have distance of the object and the focal length values, so let's plug those in. And di right here is our unknown that we're looking for. So when we subtract over this 1 over 35.5 from the 1 over 30, that gives us di equals 194 millimeters. And then for part B, we have what is the height of the image. With this, we can use the magnification equation, which is this right here. And I will also add over here that I didn't write down the height of the object is 2.55 centimeters or 25.5 millimeters. So we have all of these things here that we could plug in if we needed to. We don't need to plug the focal length in here though. So we are searching for HI because it's asking us the height of the image. And now we just plug HO in, and then be sure to get that negative sign of DI. And then we have DO 35.5. And this ends up coming to negative 139 millimeters. And this negative right here makes sense because, as we can see from our ray diagram, the image is inverted, it's upside down. And that's all for the problem. Thank you very much.